So we have 3 factorial divided by 1 factorial plus 2 factorial plus 3 factorial and so on until 100 factorial. And we're asked to solve for this. So firstly, let's create an expression that can generalize these terms. So let's look at it. In all of these fractions, the numerator will have an integer, 3, 4, 5, and so on. So let's create a variable for it. Let's say n. And notice, all of these have factorials on them. So we can write n factorial. And then we're going to divide it by, firstly, 3 factorial. 3 and 3 is the same thing. So it's going to be n factorial in here. And then 2 and 1 are just the consecutive numbers before it. So n, the number before n, is n minus 1. And don't forget factorial. And then plus by n minus 2. So basically, we're just writing down an expression that can generalize these terms. We're just looking at the patterns behind them. Like the numerators, they have integers factorial. So you put a variable for it, n factorial. And then for the denominator, they're always consecutive. 1, 2, 3, 2, 3, 4. So then we have n minus 2, n minus 1, and n. So firstly, let's simplify this expression. Well, we're going to have n factorial at the top, still. Then we're going to get divided by, well, before that, let's take a look at a cool value for factorials. Let's say 5 factorial. This is basically 5 times 4 times 3 times 2 times 1. That's just the definition of factorial. So we can express 5 factorials in another way. Firstly, let's look at 5 in here. This is basically 5. And then we can look at 4 times 3 times 2 times 1. That's basically 4 factorial. So we can use this property of factorials to simplify all of these. So firstly, n minus 2 factorial, let's just leave it be. N minus 2 factorial. And then we're going to add it with n minus 1 factorial. We can use this property to change this into being n minus 1 times by n minus 2 factorial. Just to be clear, this is basically what we've done in here. And we can do the same thing for n factorial. We can write plus by n times by n minus 1 and then times by n minus 2 factorial. It's basically all this using this property. And then we can take a look at this. N minus 2 factorial, n minus 2 factorial, and n minus 2 factorial. So we can factor out that expression. So we're going to have, don't forget the n factorial. So we're going to have n factorial divided by n minus 2 factorial. We're going to take it out, factor it. So we have n minus 2 factorial. And then the remaining are going to be, this one is basically just multiplied by 1. And then this is going to be n minus 1. So plus by n minus 1 and then n times n minus 1. So you can write it down plus by n times n minus 1. Well, firstly, we can change 1 plus n minus 1 into just being n. So that's the first thing we can do. And then we can factor out n in both sides. So we can rewrite this expression into being n factorial divided by, don't forget the n minus 2 factorial. So we have n minus 2 factorial multiplied by, we factor out the n. So we're going to get n times by, this is basically n times 1. So we're going to get 1 plus n minus 1. So 1 plus n minus 1. And 1 plus n minus 1 is basically just going to be n. So we're going to get this simplified expression, which is n factorial divided by n minus 2 factorial times by n times n, which is basically n squared. So I'm going to write n times n. And then we can simplify this even more. So let's take n factorial. We can write it down as n times by n minus 1 times by n minus 2 and so on. then we're going to divide all of that by n minus 2 factorial, which we can write down as n minus 2 times n minus 3, and so on. Then we're going to we're going to times it by n times n. So firstly, n minus 2 and so on, we can just cancel it out. So we can cancel this with this. And then the n, we can cancel one of them, this and this. So then we're left off with a simplified and neat expression, which is n minus 1 times by n. And you can verify this if you want to. You can just try out for n equals 3, 4, 5, and so on. And it's still going to be this expression. So now we're going to use this expression and then put it on this, and so on until we can simplify it. So then we now have an expression that can generalize all of these terms, which is n minus 1 divided by n. And you can try out some values for n, and we can see that this matches up. N over n minus by 1 over n. And so this value will cancel out to being 1. And then we're going to get a grand total of 1 minus 1 over n. And we can input it to all of these terms and see what's going to happen. So for n equals 3, we're going to get 1 minus 1/3, which we can also write as 2/3 if you want to. And then for n equals 4, we're going to get 1 minus 1/4, or we can write as 3/4. So then we can sum up all of these terms until 100. So we can write 2/3 plus 3/4 plus 4/5 all the way to plus by the last term, which is 99 over 100.